Now, as Gibbs free energy calculation questions go, this is one of the more straightforward ones that you could expect. Lots of information that we're going to go back and pick out from this question, but it's well worth reading through the whole thing and maybe highlighting the different parts before you begin, because it's going to make it easier for you to go back and find that information. Your start point is to consider the entropy change, the delta S. And you've got to remember this equation, that we work that out by the sum of the entropy of the products, take away the sum of the entropy of the reactants. Now, I've put those in here and I've also colour coordinated them so you can see where they've come from within the table. You'll also see that some of them are multiplied. For example, the 2 times 198. Well, the 198 is CO, and you can see that there are 2 COs in the balanced equation. So we multiply up accordingly, according to the balancing of the equation. Once I've done that, I get my entropy value, in this case 141.4 joules per Kelvin per mole. And I've actually made it to 2 marks by that point. Now, I'm going to also get a mark, and you commonly get a mark for restating the Gibbs free energy equation. So always write it down. Even then, if something goes wrong in the calculation, you're definitely going to be credited with at least that mark. And I can put the figures in. So I've got my -60, that's my delta H, which we can see highlighted in blue above. I'm then taking away T delta S. Well, T was 989 degrees C, but I have needed to convert that to kelvins. So that's where the 1262 comes from. And I'm multiplying that by delta S. But you'll notice I've divided it by 1,000. Well, my delta S was in joules per Kelvin per mole. But my delta H and my delta G are in kilojoules per mole. So I've got to convert my entropy to the kilojoules per Kelvin per mole as I have here. And that will always be the case in a Gibbs free energy question. That takes me to a value, and we're now up to 5 marks of -238 kilojoules per mole. 3 significant figures, which is the appropriate number because that's the least number of significant figures we have been given in the data that we're using to calculate it. Now, to get to the final part here, it's feasible because delta G is negative. And remember that if delta G is 0 or below 0, then the reaction is feasible.